Hello. Yes. Today we had a good discussion about what was, what is happening uh, this year, and then what's possible next year. We didn't go live because we didn't have many people, and so Christopher could spend only 2 hours, but we discussed many different things, and then but he had to go. So I just giving you a brief. Uh, Overview of what we are talking about. Uh, and essentially, what I'm showing you is a way to start physics. And we discussed that if you have conference next year in Europe, that's an idea we are working out. And we said that we could have it in Hungary, for example, in Budapest. And we say that it's a reasonable pricing and we can have rent a room, and that most likely one of the possibilities is that I go from New York, and then the flight goes via Dublin. So then Christopher will join, and then hopefully that's our plan. And then we go to Budapest, and then we plan to rent home, and it's got reasonable pricing. I think we are getting it's possible. It's a feasible plan. And then there, we can, live stream from there. And most likely we may have 10 or less than 10 people. And whoever is interested can join us, especially in our group. Uh, I think it will be affordable. About $1,000, $1,000 to $2,000, if you can spare that. But from Europe, if you are coming from Europe, it will be much less than that. You can probably drive to that place, and it will be much cheaper for you. And then we can live stream from there. We are planning less than 1 week right now because sightseeing and things like that. It could be even less than that, few days. But one day or 2 days, we'll have this conference or meeting, and then the idea is that this will set the pace for the world university, establishing world university, and start from what we call as the initial part of the physics, where we start discussing the real problem, how to solve the real problem. I think the history of physics that we have here gives a good way. And we are going to start, we also discuss about the documentary movie. And the documentary movie is going to highlight, you know, it starts highlighting each section. And it says for Galileo what started the gravity, and then it will show the highlights of the episode, and then we'll move on to this episode. The idea is that we eliminate certain possibilities, right? We know that certain things are only possible, certain other things are not possible. So, and the history of physics essentially is like a filter. It filters out other things. We know that that's not possible for physics to understand physics. And why we understand physics, things like that, will be a little bit of philosophical aspect, but not much because it's mainly historical aspects. So there is a lot of paradoxes that came into being, right, in physics. So what I'm going to do here, I'm just giving you an inkling of what the movie is that for each episode, maybe like 5 minutes, highlights of each episode. So it'll be like 15 minutes. So the total documentary movie will be less than 15 minutes. It's an informative movie of what's happening. And in that sense, we know, background details of quantum gravity, for example. And then we came into M theory, things like that. That will be episode 9. Episode will be what the emergent theory is, and then numerical relativity, and then our groups, uh, you know, started understanding the breakthroughs with different, members of our group have different ways of approach. Like uh, for me, I'm more in the time aspect and the new breakthrough in the time conservation, and also the time tensor, ranked tensor, and wave function. and how the future is going to be. Because future is like a time wave function and then collapses to a particular value, and that becomes the present. That's one of the main crux aspect. So the paradoxical aspect I have developed abstracting, and it is, there's a lot of the present uh, you know peer review paper, and it's almost ready to be published. I think it's in Galley proof level, so it should come up in a month, within a month. So that abstracting talks about the signal to noise ratio. That's what we measure, outer space or anywhere. The signal that we measure, and so, but what is the abstract connection to that? For example, a superluminar condensate. What is the connection? So the abstract thing, essentially, we have some aspect. Then we have the I, which is a Cartonian aspect. Uh, the complex aspect, which is the key thing to quantum physics, that the wave function is has both real and imaginary components. So the I comes into picture, and I comes into picture. Gamo and other people also talked about the field. Actually, is imaginary. In general, you can say field is imaginary, and then you have the particle which is real, right? And then you have the matrix. Okay, so that's where the Hilbert space and all comes in the product space, and we have the inner product, outer product, that can create a scalar value as well as uh, a density matrix. And then we have firewall, which means firewall in this sense is difference between the plant level, sub-plant level, and then the particles that we can see, electrons, positrons, and all that, protons, hadrons. So that's a firewall. So there is something behind that will be your point particles, or partons, quasi particles, or in the case of superluminar thing, they could be monopoles. Okay, so those are the firewall. There is a firewall where we can observe versus what we cannot observe. So there is an observer world and observable world. So that's where the firewall comes in. And then a particle, which becomes real, the real part. So I can put a logic here, it's a general logic, that a particle is a real aspect of these abstract. So if we develop a theory and then able to do a real aspect of it, that's what that's what the particle is. So we can define. So if we can come up with an algorithm, that's the idea, then we can do that. And some of it I have done, but there is more to be done. And some of the publications will show that. But what a interesting thing I found is this firewall is not symmetrical. And that's one thing I had found out. And that depends, go back to our consciousness. It depends on the instinct and thought, right? So the firewall has all that. I have gone to metaphysics of that, but then we apply to the mathematical physics how to do that. So the firewall, and it is an order of magnitude of flamingo. I use something called metric protocol that helps me to figure out these things. But the flamingo is one of the key as entity for dark matter. Okay, uh, and there's some discussion earlier of some people, and then we can go into details. So essentially, I'm converting this paradoxical thing into a puzzling thing. So then you have pieces of the puzzle, and we can say what it is. We can ask the question. Then we ask the question, it's meaningful. What is it? Could be answer, could be time, right? Why? Because of the history, and how is because of the physics we are going to describe. So it's essentially is a very simple way to understand the start understanding you know the physics. So that's the main aspect I want to bring out. So I want to wish you all a Merry Christmas, Happy New Year. So ha- for everybody, it's a happy holiday season greetings. Okay. Uh, I myself like the idea of Christmas, but New Year, but it's mainly holiday season that I'll be spending away from home, New York. My son is my family, like 1 or 2 weeks. That's why we have go up. And then, of course, Christopher also will be with his family, and many of you will be. So we won't have, after today, we will have almost a month break. So we won't have end up rest of it till the probably the 11th, typically right now, the 11th of January. So that will be when we'll resume the next text conference meeting. And then we'll continue with that. And by the time I hope I can probably spend some time sending emails and interest people who are interested. For example, in Hungary, we have to get more information, but it seems to be pretty good, reasonable that we can afford because our budget is very small. Maximum for me is 2,000. Actually, it should be less than that, probably like 1,000, but it could go up to 2,000, right? So if you plan for 1,000, then our budget even you know we have to have enough funds up to 2,000 because we never know what additional costs will come. So the idea in this case is to have a proper way of you know introducing the subject. Right now we have different ways of looking at things, but uh, really we talk about what was happening before us and what is happening now, essentially. So this is the main crux of the uh, conference meeting, and that will eliminate all previous things. See, we want to erase all that earlier things, which like gauge theory, kind of gauge theory eliminates extraneous or trivial things, and we want to do the same thing. We don't want to go back to the same thing, back to the blackboard when we are know that only certain things can happen. That's the main thing. So identification of the problem, if you want to call it properly. So what the problem? Once we identify, so the paradox, like I showed you, the puzzle, and I have initially said that the paradoxes are insolvable, puzzles are unsolvable because not all puzzles have solutions. But problem, when you say it's a problem, it has a solution. Then only you can call it a problem. So all problems, by definition, will have solution. But the solution may not be easy solutions. They could be difficult. Like I said, could be abstract, a lot of math, maybe involved, but we try to reduce it. My way of solving the problem is to start from the physics, understand the physics, and then from there formulate the math. I do it with Emery Taylor also. He does the logic, the physics uh, aspect, and then help to develop the math aspect. I think we are fairly successful. There are a few more things, but I think we are coming out with equations called Taylor higher equations for discontinuum signal waves. Uh, and that is different from Schrodinger equation. So that's an improvement, right? But it's still discontinuum. It's like quantum physics, but there are a lot of differences. The same way I work with Manuel Malauer at the astrophysical level, and then we have developed, the fundamental general theory and different Einstein, uh, Finsky system, and space time, different aspects of space time and how to solve the observed universe, from James Webb telescope or stars or galaxies or magnetars. So we are solve the actual thing that other people are also doing, but we are advanced, more advanced on specific aspects of space time that solves some of the problems that we see to explain how the star systems evolve and how the dynamics goes on or what happens there. Like so we are both on the quantum side as well as the astrophysical side. So I'm trying to put them together, and I describe about the time aspect. The time doesn't necessarily exist at the quantum level or astrophysical level, but mesoscopic level we have that explicitly. The time is hidden in those other places. So how that time comes out, the mesoscopic level. That's an interesting thing. And based on what I worked with Emmanuel about the point physics, and that's fundamental about the micro backwards and the zero point field theory. And that we can probably observe zero point field theory in terms of the cosmic background by connecting how it becomes that. And then the micro backward gravitational waves create. Now we can relate that, and then we should be able to observe uh, those parameters and see whether those parameters are correct. Like Emmanuel is trying to do about gravitons, and he has described a way to measure in LHC these aspects. Then Christopher has come up with the space aspect, and it should be a four-dimensional space and hyperspace. And yes, last week he presented a 120 cell model, which it solves many of the problems and can lead to theory of everything. Then Christian high space theory, where it says that there's no zero. It's all multiplicative. And then how the constants can be checked. And he has a way to check whether any theory is correct or wrong. Then John has scalar theory of everything, which is it's fundamental physics. He has shown that it should be measurable, how it should be measurable at a whole new aspect of the physics. We have to look at it in a different way. Horde, he had described about the Horde, and that's a fundamental entity. That's a dipole. And then we have Horde PDP mechanism, which creates the particle from the superluminal condensate. Then we have, uh, you know, like Gerd, Permanente, who talked about metric universe, most from the electrical point of view, how to do the circuitry. Uh, and then from that circuitry, you can calculate very important parameter, including Hubble and also the Planck level. And then that's where Wenzhong also comes into picture. He talks about how these are interrelated, the Planck and the Hubble space, and he had come up with a whole new theory of vacuum friction and other, and then superphotons and things like that. Then Andrea Gimsa and Andreas Grimsa has also uh, talked about how to incorporate gravity into electromagnetism, and these are interconnected. So every person has their own piece of the puzzle solutions, and then we put them together. Hopefully, any puzzle, you have puzzle pieces, and then holidays probably you are your all your family or the kids will be doing that. They are given just a piece of puzzle and they have to arrange them together. And once I came up with the game piece puzzle where actually it doesn't fit. That started me thinking. There are puzzles where it doesn't fit, so you have to invent new pieces or take out pieces or adjust pieces so that it will fit and make it sensible. This is what we are trying to do about the universe itself. It's a puzzle of Genesis, like I mentioned. So we all have different pieces of puzzle, and I think we can put them together. I think we have a reason to think. And I found that M brain theory may be one of the such things, specifically from quantum gravity to M brain theory, and that might be one of the solutions to the problem. But so in any way, so that those are the main things for this year, and then next year we start a whole new year, and hopefully we'll be able to find real solutions and real progress that we see the final paradigm uh, aspects described in a most wonderful way that makes sense in our mesoscopic level. That's what we are trying to do. Even though it's a quantum level, astrophysical level, finally it has to make sense. What we see in the night sky, we see star as points, right? But we know now from theory, and we have to convince our theory, yes, sun is also a star, but it's much brighter because it's much closer to us. The other stars are far away from us. Uh, but they could be much bigger. And then we can prove it in our own Earth. If you look at from a distance, they look small, like a hill or mountain. We can see it. But as we go near, they become bigger and bigger and bigger, right? And then we see is much bigger than what we are at home. We are doing it. So when we look at here at home, it seems to be much bigger than anything else. But as we go nearer their place, they seem to be much bigger. So this question of scale aspect is very important. And many species have talked about the scale aspects. That if you go to the plant level, you see something, and then in terms of dimensions and other aspects and the properties. But if you go to the astrophysical level, you see a totally different scale altogether. Mesoscope combines all that, is a conglomeration or a mixed aspect of that. So we see everything, time, space, and sense, everything together. And we ourselves, so how we came together. People like Sabine Hossenfelder talked about how the living beings came into being. And one of the recent videos, she talks about how we can understand that. So it's a lot of interesting things are going on, you know. Uh, and then we will try, we also have our own inputs. So I'm quite excited to start the new year with we are understanding. I think we have a good background. Uh, we may need some more few more basic things, but I think we have enough basics to proceed to the emergent theory aspects. So we hope to do that next year. But for reference, all the history of physics essentially gives a brief overview of all that. That's a great thing about uh, what we have done so far. We have more than 40 videos, and they are very useful in integrating all that. So hope to see you all next year. Happy New Year, and we'll all meet you next year. Until then, thank you very much. I'll sign off now.